game, part of AISL Maths. In gambling, the expected gain is the expected return, the payout, minus the amount to cost to play the game. So expected gain, which you can write as EX, is going to be your winnings minus costs. So for example, if it costs $10 to play a board game and the winner gets $10, 10 minus 10 is 0. That's a fair game. Obviously, nobody's going to play that because there's what's in it to win. What's there to win? You're only going to lose or win or make even. You can't gain any additional money. And a game is therefore set to be a fair game if the expected gain is 0. So both the dealer loses no money and the player loses no money. Now, if the expected gain is greater than 0, that's going to be good for the player. You're going to earn more money than you put in if you did it an infinite number of times. Although obviously no casino or dealer is going to play that game because they're going to just end up losing money, aren't they? They'll go bankrupt. If expected gain is less than 0, it's bad for you, the player, because you're going to keep losing money in the long run. Of course, in between, you might win some games, but on the whole, if you did it an infinite number of times, you'll lose all your money. So in that case, would you expect a gambling game to be fair? Of course not. They're in it to make profit. Let's take a look at how you would answer an expected winnings and a fair game question. A roulette wheel has 18 red numbers, 18 black numbers, and 1 green number. Each number has an equal chance of occurring. If I place a bet of $2 on red, and if a red is spun, you receive the $2 back plus another $2. So that's going to be a winning of $4. And otherwise, you lose the $2. So anything other than red, you lose $2. So we can therefore write for the blue and green, you'll get a winning. So this is for the winnings, by the way, of nothing. It'll just be the $2 you paid, and you'll get nothing out of it. If you did red, you'll get $4. You'll get your $2 back, plus an additional $2. So a winning of total of 4. Now this one over here, we're going to write our probability. Probability of each occurring. Well, red there's a total of 18 plus 18 plus 1, so 37 options, right? And 18 of them are red, so 18 out of 37. Likewise for blue. Well, I should say black, actually. Likewise for black, 18 out of 37. There's 18 black numbers. And green, 1 out of 37. You can instantly see there's a higher probability of not getting anything than getting anything, so it's probably not going to be fair, but let's find out. Expected return, if you watched the previous video, you will know it's going to be the winnings multiplied by the probability. The value multiplied by the probability. So it's 4 times 18 over 37, and it's the sum of every single one. So 0 times 18 over 37 is obviously going to be 0. Anything multiplied by 0 is 0. Likewise for green, it's going to be 0 again. That's going to mean, if you put this into your calculator, you'll get a value of $1.95. This is going to be the winnings, expected winnings. And now, if we minus it, we have a cost to play of $2, right? So it's going to be winnings of 1.95 minus the cost to play of $2. That's going to give us 0.05, 5 cents. That's going to be your expected gain, a loss of 0.05. It costs more than you're expected to win. That's going to be the expected gain from this bet, 0.05. If the same bet is made 100 times, what is the expected result? What would you expect your result to be? We're just going to multiply this 100 times. If you're going to lose 5 cents every time, you might be tempted to just multiply this by 100 and you get $5 of loss. But I wouldn't do that because this value, 1.95, is rounded. It's not the exact value. So we're going to get the exact value over here. Let me just erase this to clear up some space. So, if we have an expected value of, what was it? 72 over 37. That's 1.95 in fraction form, by the way. or the exact value. 1.95 is rounded. 72 out of 37 is your expected winnings each game. We're going to do this 100 times. So 72 out of 37. But you're going to lose the $2 of each game, right? Because this is winnings per game minus the $2 it costs to play. And you multiply that by 100, it's going to be the average expected result. And you're going to get an answer of 5.41 negative. So it's going to be a loss of 5.41. When you have rounded values like this, the key tip is to not use this value for continuation questions. Make sure you use the exact fraction and continue calculating with that value to get the exact answer. Because otherwise you would have gotten $5 and it would have been wrong. One more example, this one is slightly harder. In a carnival game, a player randomly selects a ticket from a box of tickets numbered 1 to 20. If the selected number is a multiple of 3, the player wins 5 tokens. Multiple of 10, the player wins 10 tokens. Let's calculate the probability of the player winning 5 tokens and 10 tokens. So we can draw a table of it being a multiple of 3, of it being a multiple of 10, and of it being anything else. You don't need to draw out the table for every single possible value you could get, and that's the x values. Then we have our expected payout, and we have our probability of each occurring. If you have 5 tokens, they said you win. If it's a multiple of 3, the player wins 5 tokens. Let's just convert that to dollars. Let's just say it's $5, just to make it simple. 10 tokens, 10 it's a multiple of 10, they said you win 10 tokens, so $10. Everything else, you get nothing. That's going to be 0. What's the probability of it being a multiple of 3? Well, it's the values are from 1 to 20, right? How many multiples of 3 are in 20? Just do 20 divided by 3. That's going to be 6 and some change. So there's 6 definite values within 1 to 20. And that's going to be out of 20 values. Divide 20 by 10 and you get 2. 2 out of 20 are going to be multiples of 10. Divide it by everything else, and you have 6 plus 2 is 8. 8 minus 20 is 12. That's the chance of getting everything else. You have a 12 and 20 chance of getting nothing. Would the game be fair? Let's find out. Let's calculate the probability of a player winning 5 tokens. That's really easy. It's going to be 6 out of 20, isn't it? We've already put it in the table. Let's just write it down though. 6 out of 20. 10 tokens was 2 out of 20. You can simplify it if you want in the questions. So that'll be 1/10, and that'll be 3 over 10. Now let's let x be the number of tokens won from playing this game. Find the expected value of x. Now this is when we're going to start multiplying. Payout multiplied by probability. Add that with payout multiplied by probability. Add that by payout multiplied by probability. Well, the payout's 0 for that one, so it's going to be 0. When you add this all up together, we're going to end up with a value of 2.50 tokens. We put dollars, but it's the same thing, 2.50. So that's going to be the expected return, which you can write as EX as 2.50. And if it costs 3 tokens to play the game, would you recommend playing the game many times? This is asking if the game is going to be fair. Well, you're going to get 2.50 tokens on average every single time you play. So your winnings are 2.50 minus the cost to play of 3 equals a loss of 50 cents every single time, half a token each time. So you can say as expected gain does not equal 0. It's actually less than 0, but you can just say not equal 0. It is not a fair game. It's obviously not a fair game, right? Because you will lose 0.5 tokens per 3 tokens on average. You can expect to lose. That's fair game, and I hope this helps.